we're gonna wait. I have to break. Whoa, that's big. Yeah. Okay, so we're gonna continue with physics, but we're gonna now look at some more graphs. Okay, so we're gonna look at some graphs. So these are the three different types of graphs we're gonna look at. We're gonna look at distance time graphs, we're gonna look at speed time graphs, and acceleration time graphs. Okay, so there's three different types. So first things first, let's look at. Well, let's try and make this bigger. Okay, so first things first, we're going to look at a distance time graph, okay? Everyone know what distance is, right? We know distance? Yeah, distance is how far it is, okay? What's the unit of distance? Do you remember the units? What units can we use for distance? We know like meters, we know kilometers, we know all this different stuff, right? In physics, remember, we always use meters, okay? Always meters. So we have distance, and distance is on this axis here, okay? We call this the y-axis. So we have distance here, and we have time on the x-axis, okay? So that's why we call it distance time graph. Right, so what does this tell us? Well, it tells us, let's say we have a car, okay? And the car is moving this way, and it tells us how far it moves in certain time, okay? So for example, if you read this here, what can we say? The time is what? How long has the time been? Well, if you look here, the time is 10. So that means that the car has traveled 10 seconds, okay? How far has it traveled? Well, the distance we read here, and it's 100. Okay, so what does that mean? Well, this distance is 100 meters, okay? So it travels 100 meters in 10 seconds. Does everyone understand? Amy, Alice, you understand? Are you sure? Okay, so this car has traveled 100 meters in 10 seconds, okay? So this is what the distance time graph is. Now, from a distance time graph, we can work out something called speed. Remember what speed was, right, guys? Okay, speed is sort of like fast, like how fast. And so the speed equation is this one. We did this last time a bit, okay? So distance divided by time. So what's the speed of this car? What was the distance? Well, it's just 100 divided by time, which is 10. So the speed is equal to 10. What's the units of speed? Do you remember the units of speed? We did this last time. Anyone remember the units of speed? The units of speed are meters per second, okay? Meters per second. So we always have to give the units, okay? So this distance time graph, we can work out the speed by doing this equation here, okay? Any questions? This is just the basics, okay? So this is the beginning. We're going to look at some more detail as we go along, okay? All right. Hi, is it Charlie and Timothy, right? Can you guys hear me? Okay, we're just starting some physics, okay? So we're gonna look, it's just an introductory lesson, so we're just looking at some basic stuff in physics. I'm not sure if you guys have done physics before, but if you can, just try and follow along, okay? And if you have any questions, just let me know, okay? All right, so carrying on, distance time graph, okay? So this is a new car, okay, or new vehicle, and it's telling us the distance with time, okay? So we've got different stages, okay? You can see O, A, B, C. So let's go ahead and describe each stage. So what do you think is happening from O to A? What's happening to the car? What do you think the car is doing? Anyone? Ian, any questions? Any thoughts, Ian?
No, the car moves.
Yeah, good. The car is moving. How do we know the car is moving?
Because distance is increased.
Exactly, good. So very good. So the car starts from 0. The distance is 0, right? And is moving upwards, okay? Which means the car is moving, okay? So if the car is moving, it means that the car has some speed, okay? So it's got some speed. So what's the speed? How do we work out the speed? What do you think? Alice, any thoughts? How do you think we work out the speed of this car from O to A?
Distance divided by time.
Good. Distance divided by time. Very good. So what is the distance and what is the time?
50.
Good. So from A, it's 50, 50 divided by time.
950.
Good. 50 as well. So the time here is 50, right? So 50 divided by 50, that's just simply 1 units meters per second. Okay. All right. So that's O to A. Let's look at A to B. So A to B here. Does anyone have their microphone on? Can someone, I think I can hear an echo. Do you guys hear an echo? Yeah, so A to B. What's happening to the car? Esther, A to B? What do you think happening to the car? Yeah.
This distance.
So okay, so is the car, what's the car doing? Is it moving? Is it stopped? Is it going backwards? What do you think?
Still same distance.
Same distance, right? So what does that mean? The car is doing what? What do you think the car is doing?
Speed. Same speed.
Same speed? Speed of what?
Same speed of distance.
Okay, so if you look at time 50 here, right? The distance is what? The distance is?
50.
50, good. If you look at time 100, what's the distance?
100.
What's the distance, sorry? So time 100, what's the distance?
50.
It's the same 50, right? So for time 50 and time 100, the distance is still 50. So it's the same distance. So what does that mean? What do you think that means? If it's 50 in the beginning and 50 at the end, what's the car doing? Is it moving or is it stopped?
Stop.
It's stopped, good. So for a distance time graph, if the line is horizontal line, it means the car or the vehicle is not moving. And in physics term, we call it rest, okay? So the car is at rest. It just means that the speed is 0. Okay, it's not moving, it's stopped. Okay. Timothy, Jacob, and Charlie, I know you guys are new here, right? But if you can understand it, just try and follow through, okay? So if you have any questions, do let me know, okay? Right, so from A and B, so O to A, the car is moving, speed 1. A to B, car is stopped or rest, speed 0. Let's look at B to C. So B to C, what's happening? Well, obviously it's moving upwards, right? So it means the car is now moving again. Okay, so if it's moving again, we can work out speed again. Okay, so speed, okay, is, I'll do it here. Sorry, it's a bit messy. Speed is distance divided by time, right? So what's the distance? What do you guys think the distance is going to be? The distance divided by time. So what distance shall we use and what time shall we use?
Distance is 150.
Good. It's not 200, right? Because 200 is the whole distance. B to C distance is this distance here, which is good, 150, good. And then the time?
50.
What time? Good, 50. So this time here, okay? Good. 50. So now the BC speed is 3 meters per second, okay? So this means that in B to C, the car is faster than O to A, okay? Does everyone understand? Any questions? it's just a very basic graph, okay? So I'm going to give you actually some questions to try. So let me open some questions up. Let's see. Okay, let's try this one together, okay? Everyone see this, right? So we have a distance time graph shows class 8A's journey to the zoo. So they're going to the zoo. They stop for a picnic on the way to the zoo. So you can see here, this is the graph of the journey, okay? So we have distance in the y-axis and time on the x-axis. All right. So what time did the bus leave school? So what time did the bus leave school? Alice, can you see what time the bus left?
9.
Good, 9 a.m., right? Good, 9 a.m. What time did they stop for a picnic? Okay, so Timothy, do you know what time they stopped for a picnic?
In 10 to 10:30.
10:30. Good, because that's when it stopped. Very good. Good. C, how far had they traveled when they stopped for a picnic? Jacob, do you know how to do this one?
Oh, I guess it's 50.
Good, because how do you work that out?
For the mixture.
How did you know it's 50? 50 is correct, good. But how did you know?
Because
Mhm.
straight line is on the 50. Distance from school 50. Yeah.
Exactly, very good. It starts at 50, right? But this is when it stops, doesn't it? Good. D, how long did they stop for? Charlie, how long did they stop for?
30 minutes.
Good. So that's when this is the flat line. Good. So 30 minutes. Good. And then E, what time did they arrive at the zoo? Ian, what time did they arrive at the zoo?
11:30.
11:30. Good. And finally, F, how far is the zoo from the school? Esther, how far is the zoo from the school?
How far?
Yeah, what's the distance from the school to zoo?
40 kilometer.
40? How did you say 40? This one? So they got to the school at 11:30. Okay? So they got to the zoo at 11:30. So how far is the distance?
90.
Exactly, good. 90. In this case, they did it in miles. Okay, so 19 miles from the school to zoo.
90 miles.
Yeah. Okay, so this is kind of like this is the basic stuff that you initial graph that we need to learn. Okay, so I think I want you guys to try it on your own. Okay, so let me see, find a question. Okay, can you guys see this question too, right? It's a bit small, sorry about that. But okay, question 2. Can you guys, everyone try them on their own, okay? A, B, C, D, E, F on their own, please. Okay, I'll give you like 3 minutes, so try it on your own. Okay, has everyone done it? Do you need more some time, or I think let's just try it together, okay? So part A, Amy, what time did Emma begin her journey?
In 7:30.
Good, very good. 7:30, okay? 7:30 a.m. Alice, how far was Emma from home at 8 a.m.? Part B.
20 miles.
8 a.m. Yeah, 20 miles. Good. Right. C. How long did Emma stay at her grandmother's house? Esther? How long did she stay at her grandmother's house?
1 hour 30 minutes.
Good. 1 hour, 30 minutes. D. What time did Emma leave her grandmother's house? Ian?
10 a.m.
10 a.m. How far is Emma from home at 11:45? Timothy?
7.5.
11:45. 7.5. And then F, how far did Emma travel in total? Jacob?
80 miles.
80 miles. Good. Okay. Right. That's all good. Right. So let's carry on. So that's the displacement time graph. Now we're going to move on to a different graph called a displacement time graph. Okay. So now you can see on the y-axis we have displacement. Okay. So we looked at displacement last lesson briefly. Okay. So I'm not sure about Timothy, Jacob, and Charlie, but just a quick explanation. Distance and displacement are the same thing. Okay. So distance and displacement are the same thing. The only difference is that distance has just something called a magnitude. Okay, so I'll just write it like this actually. The distance has a magnitude. Now, magnitude just means a number. So, for example, distance can be 10 meters, 100 kilometers, 100 miles. It's just got a number. Now, displacement is the same thing as distance, but it's got a magnitude and it also has a direction. So, for example, 10 meters left, 100 miles north, 10 kilometers towards Korea. That's called a displacement because it's got the number and it's also got a certain direction. Okay, so that's the difference between a distance and a displacement. Okay, it's very important because in physics we use displacement a lot. Okay, so that's why you can see here displacement time graph. We can now have a negative displacement. You can see here negative. It goes negative, right? Which doesn't make sense. But what do you think negative means? Anyone? What do you guys think negative means? So negative just means the direction. Okay, so for example, let's say I start at here. Okay, O. So if I follow this graph, is the car is moving this direction, right? It's moving in this direction. Okay. Now at here, from 10 to 30 it's stopped, but from 30 to here it's going downwards. Okay. So this just means that the car is now going backwards from the original position. Okay. So that's what this negative sign means. It's going backwards. The direction is going opposite. So going to the right is positive, going to the left is negative. Okay. So this is what a displacement time graph is. Same thing for velocity. Velocity might be a new term, but it's the same thing as speed. Okay, so speed we looked at earlier, how fast it is. Velocity has the magnitude plus direction. So for example, I can say 10 meters per second left, 100 meters per second upwards. Okay, you need to give a direction for velocity, but they mean the same thing for speed and velocity. Either way, let's look at this question here. So it's the same thing. Okay. Let's look at from here to here. So what's the velocity? We're not looking at velocity. So what's the velocity from the first journey? Alice, what do you think the velocity is in the first journey?
Five.
5? Remember, it's displacement divided by time, right? So what's the displacement?
50.
50. Are you looking at this one here, right? Displacement here.
100.
100 divided by time is? What's the time?
10.
10. Good. So the velocity is 10 meters per second, okay? Right. From here to here, we know it's stopped, okay? This is flat, so velocity is 0. Let's look at from here to here. Charlie, what do you think the velocity is from this side?
meters per second.
Good, 20 meters per second, good. But this is now where we have to introduce a plus or minus sign, okay? So plus or minus. So you can see here the car is going here and it's going downwards. If it's going downwards, it means the velocity is negative 20 meters per second. Remember before in this graph here, we only had positive, right? Positive numbers. When we're now looking at displacement time graphs, if the graph is moving downwards, the velocity is going to be a negative sign. So moving upwards, this part here, it's 10, but moving downwards is negative 20. Okay, so you have to be careful of that when we're looking at displacement time graphs. And finally, here to here, this is flat again, so it means it's just stopped again. Okay, so velocity is 0. Do you guys have any questions from this one? It should be relatively simple as well. So let me open another question up for you. No. Actually, no, I think we'll move on to the next one. Okay, so that's the displacement time graph. Now, this graph is the most difficult one. Okay, so this is called a velocity time graph. So now on the y-axis, we now have velocity. Okay, so this is the velocity just means speed with direction. So it just tells us how fast an object is at certain time, right? So let's look at this object here. So what's happening to the object? Can you describe what's happening to the object? Ian, what do you think is happening to the object? What's the object doing?
Moving.
It's moving, right? But is it moving at a constant speed or velocity, or is it getting faster, slower? What do you think?
It will moving slowly.
Okay, but is it? Mhm. Is it the same?
It will moving slowly.
It will move
Yes,
slowly.
it will moving Yes.
Okay, so is it slowly all the time, or is it just getting faster, slower, or the same?
Yes.
Okay.
Can I hear one more time?
All right. So so let me describe it for you. Okay. So when the time is 0, okay. So at this time here, the time is 0, guys. Okay. So that means what's the velocity when it's here? Well, the velocity is also 0. Okay. So that just means that in the beginning, the car or the object is stopped. It's at rest, not moving. But as time goes, you can see that the velocity is also getting higher. So what does that mean? The car is getting faster and faster and faster as time goes, okay? So the car is speeding upwards, okay? So the velocity is not the same. It's always changing. It's always getting bigger, bigger, bigger. In this case, what we say the car is accelerating, acceleration. The car is getting faster, okay? It's a new term in physics, but it's called acceleration. This is when the car or the object is getting faster, faster, faster. So for a velocity time graph, we can actually work out the acceleration, okay? And the acceleration is this equation here, velocity divided by time, or the gradient, okay? Gradient is a maths term, but gradient just means how steep it is. I think you guys have done it in maths anyway, right? How steep the line is. This gradient tells us the acceleration of the vehicle. So let's work it out. So what do you think the acceleration is? Well, if you look at the triangle, then it's going to be 50 divided by 10, just 5, okay? And it's got a weird unit, but we use meters per second squared for acceleration, okay? So the car is accelerating at 5 meters per second squared. Any questions so far? All right, let's move on. So that's this for velocity time graph. There's two things that we can work out. Okay, so number one was acceleration. Number two is the distance. Okay, so we can work out the distance traveled. So this is the second thing we can work out. And the distance traveled is found by the area under the graph. Okay, so if this is still a velocity time graph, so we know that the gradient here, this is the acceleration. Remember we looked at last slide. The distance is this here, okay? If I draw a triangle, then this triangle, this area, tells us the distance traveled by the vehicle. So in this case, 50 times 10 divided by 2, okay? So this is 250 meters. So the car or the vehicle has traveled 250 meters. Okay, so that's what, for velocity time graph, I want you guys to remember two things. The acceleration and the distance, how we work it out. All right, let's look at this velocity time graph here. It's a bit more difficult, okay? So let's look at each individual stage. I'll split it up. So let's go O, A, B, C, D. Okay, so we have velocity against time. So O to A, we can say the car is getting faster, right? So we say it's accelerating. So if it's accelerating, what does it mean? We can work it out. So how do you work acceleration? Esther, how do you think we can work acceleration? Or Charlie, how do you work at the acceleration?
500.
500? How did you get 500?
100 multiply 10 and divide 2.
Okay, good. But remember, that is for the distance. If you want to work out distance, then that's 500. Good. But I want to work out acceleration. Okay, so how do I work out acceleration?
5.
Good. Sorry, not 5.
10.
10. Good, 10. Because acceleration is the gradient. So 100 divided by 10, 10 meters per second squared. Okay. A to B, the car what do you think, guys? Do you think the car, or Timothy, what do you think? Is the car moving or stopped?
I think car is stopped.
It's stopped. Why do you think the car is stopped?
Not stop moving.
It's moving, right? It's not stopped, it's moving. How do we know it's moving?
Because the time is flowing in here.
Yeah, and the velocity, yeah, good, is 100, right?
Going on.
Good. So even if it's flat, the car is moving it. That's why to be very careful what the graph is. Remember, up here, we did distance time graph, right? And when it's flat, we said, oh, it's stopped. But when we're looking at a velocity time graph, if it's flat, it does not mean stopped. It means it's still moving, okay? So to be very careful what kind of graph we're looking at. So A to B, the car is still moving, okay? But the acceleration is 0. So it's the same speed, same velocity, same 100 all the time from A to B. Okay. B to C. Jacob, what do you think is happening from B to C?
Decreasing.
Good. But what do you think is decreasing? What is decreasing?
Accelerating.
It's accelerating. Oh, good. Okay, so the car is decreasing the speed, right? So acceleration. Okay. Good. So when it's decreasing, we give it a special name, okay? So we call it decelerating. Increasing means accelerating, decreasing is decelerating. It's a very special name in physics terms, okay? So we have acceleration going faster, deceleration going slower. And we can work this out. So Jacob, what do you think the deceleration is in this case? B to C.
minus 10.
Minus 10? How did you get minus 10?
No, wait a second.
Mhm.
2.5.
Minus
Minus
2.5.
2.5.
Close, very close. So if you look at B to C here, right? So it's the velocity. So what's the velocity from B to C? What do you guys think? What's the time? What's the time first? What's the time?
Time 40.
You have to be careful, okay? Because B to C, B starts at 30 and C finishes at 40, right? So the time is this time here. So it's going to be 10.
10.
Yeah. What's the velocity? Well, it starts from 100 and it finishes at minus 100. So the difference is minus 200. So the velocity is minus 200, okay? Which is just minus 20 meters per second squared. That's how we work out deceleration, okay? So just be careful what we're looking at, okay? And then finally, C to D, this is also horizontal, same as A to B. So that means that the acceleration is 0, same velocity, no change in velocity, just the same constant one. Okay. So this is, I know it's quite new for some of you guys, so just try and follow along as best as possible, okay? So right, so that's the acceleration. We can, remember, for velocity time graph, we can work out two things, right? We can work out acceleration. We can also work out distance traveled, okay? So this is the acceleration part. Let's try and work out the distance traveled, okay? So distance traveled. And remember, the distance traveled can be worked out by the area. So the area underneath the graph. So let's split it up each once, okay? So let's say O to A. Alice, what do you think the distance traveled from O to A is?
Mm, 100.
100? How did you find 100?
Mm, I don't know.
Okay, so remember the distance is the area, okay? So this is, if you look at this area here, this is just a triangle, right? So how do you find the area of a triangle?
Multiply by 100, multiply 10, divide 2.
Exactly, good. So the area traveled from O to A is just 500 meters. Okay. Let's call this B now. Okay, so A to B. Amy, how do you think we work out the area for A to B? What do you think the distance traveled from A to B is?
Mm, 2.
To
Mm,
this is 20. This is 100. So the area is
100.
200, right? 2,000 actually. If it's 20 times 100, 2,000. Okay? 2,000 meters. All right, so this is where it gets a bit more difficult, okay? So let's call this, actually, let's call this C and let's call this D here. Timothy, B to C, what do you think the area is for B to C?
I think 250.
Good. 100 times the time is now half, right? So 5 divided by 2, 250. Good. Right. C to D. Ian, C to D?
Also 250.
This is also 250. And then D to E, this is simple as well. I'll just D to E. This is 10, 100, so 1,000 meters, okay? So this is the individual distances from each stage, okay? So that finding the individual distances is relatively easy, okay? So doing this was relatively easy because it's always going to be triangles or rectangles. The one thing we have to work out is, well, if the distance is underneath this graph, right? So this section here, the distances we have to actually change to minus. So O to A is plus 500. A to B is plus 2,000, B to C is plus 250, but C to D is this section here, right? And it's underneath the graph, which means that the car is moving backwards, okay? So C to D is actually negative 250. Same thing for D to E, because it's underneath the graph, it's negative 1,000. Okay, so if you find the numbers, you also have to find is it positive or negative. And it's just simply, is it above the graph or below the graph? So if I asked you what's the total distance traveled by the whole vehicle, then we can just plus all these numbers together to find the total distance. Okay. So that's the two things, okay? So we can work out for velocity time graph, we can work out acceleration, which is the gradient, and we can work out the distance traveled, which is the area underneath the graph. Okay. All right, the questions do get a bit difficult for this type of graph, okay? So I'm going to give you some questions to try, actually. Let's see. I don't know how to make the question smaller, so all right, let's just look at this one here, okay? So it's quite a difficult one. So a sprinter runs a race of 200 meters. Her total time for running the race is 25 seconds. Below is a sketch of they call it speed, but speak of velocity, okay? So here is a sketch of a speed time graph with the motion of the sprinter. So this is the sprinter's speed time graph, okay? So she runs 200 meters, 25 seconds, okay? That's why it's 25 seconds like this. So there's a couple of things we can see. It's like the speed, it goes up to 9. We have this weird U speed as well, okay? So U. Right, calculate the acceleration in the first 4 seconds. So how do you work out the acceleration?